Right, we're going to turn our attention now to the main feature segment here, where we are going to be talking about, well, cloud security, specifically your cloud security journey here on various key trends, capabilities, and skills. So let me go ahead and advance to the next slide here. And for those of you that I have not met, just a quick background here. I've been teaching writing courses with SANS for a long time now, for 16 years. Was the CISO here at SANS for a little bit. Still currently lead our cybersecurity leadership, as well as our cloud security curriculum. I'm also the CISO-in-Residence at a venture capital firm called YL Ventures. If at any point in time you would like to connect, chat about anything that might be coming up in cloud security or cybersecurity overall, feel free to connect with me on LinkedIn or go ahead and send me a message. In terms of our topics that we are going to be covering today, well, in our limited time together, there are 3 things that we're going to be discussing. And this is based upon conversations that I've had over the last several years, actually, with many cloud security practitioners, cybersecurity leaders, security officers, and CISOs. And various organizations are grappling and dealing with these same 3 trends. Number 1 is multi-cloud. Not very long ago, various organizations found themselves trying to figure out, well, how do they work with the one cloud provider that they have decided to use? Well, it turns out every organization of any size is really multi-cloud. Multi-cloud, well, by choice or by chance. By choice, because they made a specific business or technical decision to support and use multiple cloud providers, AWS, Azure, Google Cloud, and or by chance, by virtue of acquisition, by virtue of geography, by a little bit of accident, if you will. So that is multi-cloud. And we've also got architecture here. As organizations are maturing, they realize they need to take a step back and not just deploy features and functionality into the cloud at just a rapid pace, but they need to step back and say, are we designing this appropriately? Do we have the right protections, the right design in place? So if any of you are dealing with any of these, I'm going to ask you a question. If you can, chime into the chat. Which of these 3 things, multi-cloud, architecture, or automation, for you right now seem to be the biggest priority? Just go ahead and type in one word, multi-cloud, architecture, automation. You could, if you want, type in all. Because what we see is when you're using multiple clouds, when you are ideally designing it right from the start, you also need to figure out how do you automate these various capabilities, include your security best practices in your automated pipelines to make sure that your security checks, your security tests, and perhaps even tools like Kat is going to talk about a little bit later on in this show, how you can automate some of these checks inside of your automated pipelines across your organization. And I see it's very interesting here. A lot of people chiming in here with automation as being the number 1 driver. That's also very associated with AI. One of the things that AI can help with is some of these automation activities. It's also interesting here that many of you are chiming in with architecture, working on trying to figure out how to, yes, get those security protections in place in a standard way. But also interesting that nobody has mentioned multi-cloud, and it might very well be that is because, hey, you might just be multi-cloud. That is just natural, the natural way of working now. So let's go ahead, and before we dive in, let's do a quick reminder here on the next slide. And as Nicholas mentions, all 3 are critical and they complement each other. I see somebody from LinkedIn chiming in that says they are focusing on multi-cloud right now. And what you see here on this slide is your cloud infrastructure and platform landscape. And of course, we've got the Gartner Magic Quadrant on the left-hand side here. We've got the Gartner Magic Quadrant all the way back from 2014. And you can see just at a glance that the landscape was a lot more crowded. In the upper left-hand corner of the left-hand graph, you've of course got AWS, Amazon Web Services, as the clear leader in the space. But if you fast forward to the most recent Gartner Magic Quadrant, and this is where I will ask you all to, again, chime in here in chat and just go ahead and type in Which cloud provider are you primarily using at work today? If you're using two 50/50, go ahead and chime in with both. But whether that be AWS on the right-hand side, whether that be Azure, or whether that be Google Cloud, feel free, please go ahead and chime in here because you can see in the latest version of the Gartner Magic Quadrant that those are the clear big three from a cloud service provider perspective. But in the lower right-hand quadrant, you can see that we've got Alibaba, right, has been making a lot of strides in recent years. You can see Oracle Cloud, which some organizations have been adopting as well. And in the lower left-hand quadrant, well, you've got the various niche players. You've got IBM, and of course, you've got Tencent and Huawei over in the Asia region, the APAC region. I see a lot of people chiming in here with primarily AWS, Azure, some GCP. We even have some people chiming in with some Oracle usage here. And a lot of times I find that Oracle is not necessarily right the primary cloud provider, but from a business perspective, some organizations have decided to mitigate their business risk by using a secondary or another cloud provider like an Oracle here. All right, thank you all for chiming in. That is very helpful for us to all see which cloud providers you guys are primarily using. With that, let's go into our first of three topics, specifically multi-cloud. Now, every single year in recent times, SANS has been publishing a multi-cloud, a cloud security survey. The most recent one was conducted by Brandon Evans and Ken Hartman, fellow SANS instructors. And what they have found that, you know what, it's exactly what we just said. So we've got a little bit of a survey-based, a little bit of a data-driven approach to highlight the fact that, hey, those big three cloud service providers are used multiple times in multiple organizations. In fact, the big six, if you will, to include Oracle, Alibaba, and IBM, right, those have decent usage across various organizations as well. And what does this mean for us from a security perspective? Well, this is a term that Brandon likes to throw around in terms of cloud agnosticism, is that we as security professionals, because we are living, operating in a world where our businesses are using multiple cloud providers, it's not on us to make that decision. It means that we as security professionals, well, we have to be knowledgeable about all of those cloud providers and the nuances, the differences of what we need to do to secure them. Now, this can get a little bit complicated, a little bit hairy. How do we figure out if you are just getting started in your journey, what do you need to do to secure these various cloud services? Well, fortunately, this is where the CIS, the Center for Internet Security, publishes their benchmarks for various technologies, including the cloud providers that we see here on the slide. And you can go download these documents and see, well, what are the cloud security best practices from a configuration perspective. If you use these CIS benchmarks for cloud or for anything else, feel free, please go ahead and chime in with a +1 or a thumbs up in chat just to confirm that you do use these. Now, it is important to note that while these CIS benchmarks cover the foundational areas like IAM, logging, monitoring, networking, storage, and so on, well, these CIS benchmarks do not cover every single service that the cloud providers provide. It's not a day, not a week goes by that the cloud providers update and publish new services. Aksh, thank you so much for chiming in, saying that you do use the CIS benchmarks. Appreciate it. Now, while we know that there are some limitations, the CIS benchmarks are a great starting point. However, when you go to download the CIS benchmarks, it's really just a checklist. It takes a lot of work for you to turn these into reality. Well, as a result, we have various cloud security tools that you can use, various commercial versions, but also there are various open source versions of these tools. I will say, to keep this simple here, we've got the three most common cloud security tools. And hey, we mentioned Gartner earlier. Gartner's job seemingly is to partially come up with new acronyms to describe various categories of tools. So I'm going to ask you to chime in here, and we're going to ask you a little survey question. Which cloud security tools? Is it a CSPM? Is it a CWPP, Cloud Workload Protection Platform? Is it a CASB? Or is it something else that you primarily use? So as you guys are chiming in here and entering in your responses to this survey, I'm going to go ahead and talk a little bit more about these three tools to set the stage. CSPM, Cloud Security Posture Management. It is scanning all of your public cloud infrastructure and platform as a service offerings, really looking for the equivalent of those open windows, those broken windows, those unlocked doors, where you got a cloud security specific misconfiguration. CSPM is basically on its way to becoming the vulnerability scanner for your cloud environment, like you have your traditional vulnerability scanners. So really that is focused on, well, yes, your cloud infrastructure and platform offerings. And again, feel free, go ahead and please chime in here into the survey at your leisure. But then in the middle, you've got your cloud workload protection platforms. This is what provides security for your quote unquote cloud native infrastructure. Now, you've got the CNCF, your Cloud Native Computing Foundation, that defines cloud native as any cloud related technologies that support applications and services that are deployed into your public cloud providers. So this is security related to things like containers, Kubernetes, Docker, your various API resources, and so on. And then finally, you've got your CASBs here, You've got your cloud access security brokers that are specifically providing security and visibility for your various SaaS services. So here on the next slide, really from an architecture perspective, modern architecture perspective, it is no longer that hard, crunchy exterior, but it is, well, a decentralized, a distributed, a deperimeterized, if you will, architecture where you've got infrastructure and platform services. You've got still, yes, perhaps your legacy on-premise data center at the 7 o'clock position here, but also around the right side of this circle, you've got your various SaaS offerings. So related to the tools that we just talked about, the CSPMs really only apply, yes, to those public cloud infrastructure and platform providers in terms of that security scanning and visibility. And then your cloud workload protection platforms, those are for any cloud native workloads that are deployed either into your public cloud or even within your legacy data center. Yeah, you can certainly run containers and Kubernetes inside of your legacy environment as well. And then, of course, finally, you've got your CASBs here that are specifically for your software as a service, for your Microsoft 365, Google Workspace, and so on. I see some of you have chimed in here in terms of the usage of that tool, these various tools, so appreciate it very much. Now, Aksh specifically mentions AWS Guard Duty. Now, in terms of Guard Duty, what that does is it looks for, finds, well, different alerts. That's AWS's kind of threat detection service. That's related exactly with what Kat is going to be talking about in her demo a little bit later. So with that as a little bit of a teaser here into architecture, let's segue into item number 2. Now, I see somebody here comments online that says, hey, you built your own security tools by fixing Kali scripts, writing an application called Reaper to identify rooted security issues such as MFA weaknesses. For example, that's something that Guard Duty and other services will try to do as well. And then doing some additional testing and code review for known memory leaks. So very nicely done. Sounds like a very cool approach that you have developed in-house. With that, let's go ahead and move on and talk a little bit about architecture. Now, Kat actually wrote an entire course, co-authored an entire course on enterprise security architecture. We don't have time to go into all of those details, but one of the important elements of how you think about your cloud architecture is related to identity and your hierarchy that you define in the cloud, your hierarchical account structures. And especially given the fact that we live in a multi-cloud world, it's important to consider the similarities and the differences in terms of how the big 3 cloud providers allow you to do exactly this. For AWS in particular. Now, when AWS first started, it was a little bit unstructured, I would say. Hey, you spun up an account, you deployed various resources into account, and you got stuff done. As time went on, well, it turned out that many organizations and enterprises would use the AWS account as the boundary, even as the security boundary for containing those various resources and the different types of workloads therein. But this resulted in a situation with organizations having hundreds, thousands, in some cases tens of thousands of AWS accounts. It gets a little bit unwieldy. So this is why AWS introduced the concept of a management account that could contain various organizational units, related organizational units that then had various accounts contained within them to make management a little bit easier. All right, so that is the AWS structure. Azure structure here in the middle is a little bit different. Well, as you hopefully have noticed, instead of having 4 tiers like AWS, there are 5 tiers, starting at the top with the root management group that is comprised of different management groups and a corresponding subscription. Now, the subscription is roughly equivalent to what we call the AWS account over on the Amazon side. And then the subscription can contain multiple resource groups, which then can contain have various resources, the cloud resources that you use and actually deploy. The key difference here are the resource groups, and that is a very convenient mechanism that Azure has created that you can use to, yes, well, as the name implies, group various resources. And because Azure has a very sensible hierarchical structure, if you apply any permissions, grant permissions to different levels of this hierarchy, those are inherited on down. Very convenient way to structure things. Google Cloud on the far right-hand side, slightly different nomenclature. You've got the organization at the top, which contains different folders. Then you've got the project, which is roughly equivalent to the subscription and the account in Azure and AWS respectively, which then contains the various resources. All right, so now, if that is the hierarchy, how do you go about enforcing these policies in your cloud architecture overall? AWS on the left-hand side here has what they call service control policies. It's important to keep in mind that these service control policies only block things from happening, right? You can prevent a service, a particular service, maybe an expensive service, from being used. You can prevent certain things from being deployed in certain regions where maybe you do not have infrastructure and you don't do business, but it doesn't grant any privileges, right? So there's sometimes a little bit of a complicated interaction with IAM, but the main thing here is that service SCPs only prevent certain things from being done within the account boundary associated with your organizational unit. And there is no audit mode that occurs. Azure policy, on the other hand, is a little bit more robust, a little bit more comprehensive. It can not only restrict what can be deployed or not, but you can have audit mode that's enabled, but also it can remediate non-compliant resources. If it finds something that is deployed that is not aligned with your specification, it can go ahead and either tear down that resource or redeploy an updated resource that meets your specific security requirements. So it's pretty powerful. Google Cloud on the far right-hand side, similar to AWS, constrains what you can do across your entire hierarchy. It's got many out-of-the-box constraints, but you can configure things based upon certain values or a true-false type of configuration. Similar to AWS, there is no audit mode available. So Azure's, again, is a little bit more full-functioned and a little bit more robust. All right, so this gets us now to the AWS Security Reference Architecture. If anybody has looked at, downloaded, or even seen the AWS Security Reference Architecture that was published, I think a couple years ago, please go ahead and chime in here in the chat with a +1. Now, we're specifically mentioning AWS's architecture as reference as an example here, because they define a number of really good best practices. As you can see here, you've got that org management account that we mentioned, but one of their big suggestions is you go ahead and define multiple organizational units. Like you see here on the left-hand side, an OU for security, an OU for infrastructure, and an OU for your various application workloads. Now, in reality, you're probably going to have multiple OUs for your different workloads, your different business applications. And let's go ahead on the next slide here and zoom in to the security reference architecture for the security OU. And you can see that AWS suggests that you should have an org management account. Looks like, sorry if I'm going to mispronounce this, but Damilola, right? Damilola chimes in and says, hey, yeah, you have used the AWS reference architecture before. You've got your central org management account, but you also define a separate tooling account. And also, common best practice is to define a separate log archive account, a read-only account where all of your logs are flowing. And the reason that we mentioned these AWS security-related services on the left-hand side of this slide is not that you have to use all of these services, is that these are the ones in the reference architecture that, hey, are available to you to potentially deploy even to other accounts like your log archive account on the far right. With that, this brings us to number 3 out of 3, our last trend that we're going to be discussing today, which is all about automation. Now, when I first started my career, I'm going to ask you guys to guess, and this is something that I commonly ask people because I'm very curious to see what people's guesses are. When I had my first job many years ago, it was a long, long time ago, I'm going to ask you to guess, how many times per year did we deploy an updated version of the application to production? Please chime in here in the chat. How many times per year did we deploy an updated version of our app to production? While you guys are chiming in, I'm going to go ahead and move on and talk about this and glance back at the chat here to see what your responses actually are. And what we talk about from an automation perspective is, one, well, we've got to understand the automation that is being used by our engineering and DevOps teams. And the backbone of this is our CI/CD pipeline, our continuous integration and continuous delivery pipeline here that walks us all the way from pre-commit to deploying the application in operations on the far right-hand side. Now, Joe has a very good guess, guessing that we walked through, well, the version that we had of that pipeline back then, 26 times, once every 2 weeks. No, unfortunately, it wasn't that much. Sean mentions quarterly, 4 times a year. Shannon mentions twice a year, right? Momoka mentions less than 10. Elliot mentions 1 to 2. So we've got a range here. Ezekiel, that's a good guess as well, with 2. Somebody else guesses 12. We've got a range from 1 to 26. Well, to tell you the truth, we deployed to production, it was horrible. 0.7 times a year. We deployed to production once every 18 months. And the reason for this is it was because it was a long, laborious waterfall development process. It was not the more streamlined CI/CD process that you see here on the slide. So it was only until many years later, right, that now, hey, we've got various tools like we see here on the next slide, like, well, your traditional CI/CD tool Jenkins, but now your various cloud-based tools like GitHub Actions, GitLab CI/CD, and having modern version control systems that are based on Git, right? Back in the day, I used many old version control systems like, it was horrible, Microsoft SourceSafe, Subversion, and so on. But now, right, the whole industry has standardized on the foundations of our DevOps tool chain being these CI/CD tools and our version control systems based on Git. So if we have an example here with Jenkins, you can see on the far left-hand side, we've got the commit phase that's kicked off by pre-commit. That's not shown further left here. Anytime some code is checked in, right, somebody does a git commit and a git push, this commit phase automatically kicks off to run, well, even some static analysis tools, builds the corresponding container that is then deployed to the acceptance environment with some additional tests being run, that is deployed to other environments and then deployed either locally in your on-premise environment or right to your various cloud environments as well in an automated way. We didn't have this back when I was doing 0.7 deploys per year. And we mentioned this here because one of the things that we want to automate is the search. It's the search for security issues. I'm going to ask you to chime in here and in chat. And if you identify any security-related vulnerabilities here in this Docker file, please go ahead and add in the line number. Because just in a few moments, I'm going to switch to the next slide where we reveal the security issues associated with this Docker file. Now, of course, the Docker file is the file that allows you to define what is going to go into the container that is hosting, that is the container for your application functionality. And there are a number of different vulnerabilities that are in this particular Docker file. Right, so I'm going to go ahead and reveal, right, what these are real quick. I see Anani already chimed in with line number 15. Thank you very much. Hey, I owe you a drink if we are ever able to meet in person, because line number 15 has the application running as root. Yes, we ideally do not want to do that, but we got a number of other issues here. A software supply issue on line number 1 with an incorrect registry pointing to MCR RN Microsoft, not Microsoft.com. We've got an older version of the SDK that might have some vulnerabilities. We've got hard-coded secret on line number 5, pinning the package version in line number 7 to a version that potentially is outdated and has some vulnerabilities. So many of you chimed in correctly with line number 15 as the root user. I think Servet is pointing out that maybe the whole thing is vulnerable, right? Which we definitely see here as well. So thank you guys for doing that quick code review. And we mentioned this here as an example of one of the tools that you could automate, one of the types of checks that you can automate, because you've got various open source tools. We're only showing the open source versions here. There are some commercial versions of some of these tools, but this is where on the left-hand side, you can scan your Docker file for vulnerabilities like we just did in the Docker file, but you can also, right, scan your running containers using some of the tools we see over here on the right-hand side. So what we just talked about here before I turn it over to Kat, well, was multi-cloud, was architecture, and was automation. And this is all related to, well, your cloud security journey, your team's cloud security journey, and your organization's cloud security journey. Whether you are in an analyst role, an engineer role, an architect role, whether you're focused on DevSecOps or detection and response from a security operations and SOC perspective, right? What we've got here are the various cloud ACE journeys that are associated with various courses. We, in fact, have a course dedicated to public cloud security, effectively multi-cloud in Sec 510, that hopefully you can see is used across multiple of these various journeys. We've got a course 540 all about cloud and DevSecOps automation. That is the pillar of a number of these journeys as well. And then, of course, we've got Kat's new course, Sec 549, that is all about enterprise cloud security architecture. All right. So I encourage you to learn more about these various journeys on the SANS website here.